Alright, so have you come across questions like this in physics or this one as well? So these questions are usually coming out from Kirchhoff rule. Okay, so welcome back to this class. In this class, you have teaching guys all you need to know about Kirchhoff rule as well as complex DC circuit. Okay, now this class is divided into two parts. The first part talk about Kirchhoff rule, while the second part will deal with what potential divider. Now, if you look at the board, you see a particular question on the board. They said, if you look at this, is a complex DC circuit. Okay, now in this question, they said find the currents. Look at it, they put S. Find the currents. So this is one current, this is another current, this is another current. Okay. Now you might be wondering how are you going to solve this type of question? This type of question, to solve them, we need to know Kirchhoff rule. Okay. So now what is Kirchhoff rule? Now remember, there are two Kirchhoff rules. Okay. Now the very first rule is known as the junction rule. All right. So the first rule is known as the junction rule. The second rule is known as what? It's known as the loop rule. Okay. So please take note of all these things. Now, what does junction rule state? Now, junction rule state that the current entering a junction, okay, let's say the current here is 5 ampere. All right, so this is a junction. So, junction rule state that the current entering a junction usually equals the current leaving the junction. Okay, usually equals the current leaving the junction. Okay, usually equals the current leaving the junction. Now, the current entering a junction, okay, the current entering a junction usually equals to what? The current leaving the junction, right? Now, where is the current entering? This is the junction. Now, where is the current entering the junction? Here, the current entering the junction here is what? Is 5 ampere, right? Yes. Now, what about the current leaving this junction? Current leaving junction is still what? It's still 5 ampere because where? If you had these two currents, you get what? You get 5, right? So that is junction rule for you. Junction rule state that the current entering a junction usually equals the current leaving a junction. Now let me ask you guys a particular question. Now, for example, you come across something like this. Okay, you come across something like this, for example, and they put 2 ampere here and they put 1 ampere here. And they will ask you, what is S? S here will be what? S here will be what? S here will be theory, right? Yes, because this is junction, because the current entering a junction usually equals the current leaving the junction, right? How many currents leaving the junction? The current leaving the junction, 2 plus 1 is 3, right? So there are 3 ampere is leaving the junction, right? Yes. So according to the junction rule, the current entering junction usually equals the current leaving a junction. Okay, so please have that in mind. Okay, it's very, very important. Okay, yes, you need to know these rules before we can start solving questions like this in regarding Kirchhoff rule. Okay, yes. Now, what is the next rule? The next rule is what? The next rule is known as the loop rule. Okay, the next rule is known as the loop rule. Now, what does loop rule state? Now, loop rule state that the total voltage, or you can say total EMF, okay? So, or you can say total potential difference, all right? So, let me use potential difference. Now, loop rule says that the total potential difference across each component of a circuit usually equals what? Usually equals 0, okay? Yeah, so the sum of the potential difference across each component of a circuit, this is a circuit, right? This is a circuit, okay? So, what loop rule says that the total, or you can say the sum of the potential difference across each component of a circuit usually equals to what? Usually equals 0. So that is what loop rule states, right? So in summing to these two rules, the first rule is junction rule, right? What does junction rule tells us? Junction rule tells us that the current entering a junction usually equals what? The current leaving a junction. While loop rule, what does loop rule tell us? Loop rule tells us that the total potential difference across each component of a circuit usually equals to what? 0, right? So take note of these two rules. Now, apart from taking note of these two rules, there are also some sign convention you need to know, okay, before we start solving questions. Before we start solving questions, okay? Now how can you apply Kirchhoff rule? This is very important. How can you apply Kirchhoff rule to circuit like this? Okay, yes, how can you apply Kirchhoff rule? Now there are so many things I need to tell you guys. Now the very first thing you need to know is that current always move from where? Current always move from a point of what? A point of higher potential, right? A point of higher potential to what? To a point of what? Low potential, right? Yes, that is very, very important. Okay. So current move from what? From a point of high potential to what? A point of low potential. Okay. Now just imagine just imagine a slope. Okay. If there is water here, there's usually inside energy. There's usually this water here. Let's say there's water at the top of this slope, and there's no water here. Now you find out that the potential here is usually very high compared to the potential here, right? This part have higher potential, while this one have a low potential. So therefore, there's a greater tendency that water usually flow from this place of high potential to this place of what? To this place of lower potential. So that happens in that same happens to what? To current. Current always move from what? From high potential to what? To low potential. That is very, very important. Okay. Now how to apply Kirchhoff rule? Very easy. Okay. So in order to apply Kirchhoff rule, at first you need to at first you need to know the you need to give each circuit to a loop. Okay. Yes, you need to give each circuit what? A closed loop. That is very important. Okay. Now you can, okay, let's say for example you can say, okay, this part, if you look at this diagram in the board, you find that should I say it's made up of two closed loop, right? Yes, if you look at it, this is one of the loop. All right, so this is one of the loop, this one of the loop, this one of the loop, right? Yes, the other loop is this one. All right, so you find that it's made up of two closed loop, right? This is one of the loop like this. All right, so like this. The other loop is what? The other loop, okay, no, this one of the loop, right? So the other loop is what? Like this. Okay, then like this. So it's made up of what? It's made up of two closed loop, right? Yes. So at first you need to assign direction of the loop. Very important. Okay, so that is the first you need to do. At first, check numbers of loop, right? So there are how many loops here? There are usually two loops here, right? If you look at this question, if you look at this one in the board, there are also two loop. This is one. You can just this is one. This is another one. There are two loop. Same goes for this one. There's also two loop, right? This is one loop. This is another loop, right? Yes. So at first, know the numbers of loop in this in the circuit. Then the next thing you need to know is to assign the direction to the loop, right? Yes, the direction can be clockwise, can be anti-clockwise. Okay. Now, what do I mean by clockwise direction? You can say, okay, the direction of this loop here will be something like this. Okay. Yes, it means that you start from here, you go like this, you go like this, you go like this, go like this, go like this, go like this, you end here, right? So assign direction to a loop. This is a clockwise direction. So just tell them that the direction of the loop might either you choose a clockwise direction or an anti-clockwise direction, doesn't matter. Okay, so we can say we can so let's assign direction to this first loop. So this first loop, let's say, okay, this is the direction of this first loop is what? Is clockwise, right? So we start from here, we go like this, go like this, go like this, we end here, right? Then we assign direction to the second loop. We can say the second direction of the second loop is still clockwise, right? It means that we start from here, we go like this, go like this, go like this, right? Yes. You can also assign an anti-clockwise loop. You can say the direction of this loop is like this. It means that we start from we start from here, go like this, 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 end here, right? Yes. So it means that we start from here, go like this, go like this, go like this, go like this, end here, right? Yes. You can say, okay, this other one will still be anti-clockwise, like this. All right, right? Anti-clockwise means that we start from where? You can start from here, okay, right? Yes, means I start from here, go like this clockwise. Okay, so we can say anti-clockwise. Give one anti-clockwise. It means I will start from here, right? It means I start from here, go like this, right? So the direction of the loop does not matter. Okay, so the first thing is to know the numbers of loop in the circuit. So how many loops are in this circuit here? There are two loops, right? Yes. The second thing you need to do is to assign direction to the loop. Okay, so let's just give these two loops clockwise direction. Okay, so like this direction of this first loop, direction of this first loop is what is clockwise, right? So we start from where we go like this, 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 end here. Then the second one, we also give what? A clockwise and loop, right? Yes, it means I will start from here, we go like this, go like this, go like this, go like this, end here, right? Yes. So that is just it. Okay. So the first thing to know is to first thing you need to do is to what? Know the numbers of loop, right? Get numbers of loops, then assign direction, assign direction to the loop, right? Yes, can be clockwise, can be what? Can be anti-clockwise. Okay, yes. Now, the next thing we are going to do, this is very important, okay? This I think this is one of the most important things. Okay, so the first one, we know the numbers of loop, right? There are two loops. Second one is to assign direction for the loop, right? Yes, can be clockwise, can be anti-clockwise, any direction you choose, all right? Then this next thing you need to know is that when we move, this is very important. Remember, this is what this symbol here is a cell. You can say a battery, right? This is battery, right? This is what this is also this is a battery. This is a battery. This is what this is a battery. This is a battery, right? So you can say a cell, right? What they produce energy, right? Yes. Now, I've told you guys in a previous class that when it's not like battery, this long terminal is usually known as what? The positive terminal. While this part is known as what? The negative terminal. Okay. Now take note. When we travel, this is very important. When we travel, and when we travel from when we travel, okay, when we travel from okay, you can say when traveling, when traveling, when traveling from the negative terminal, from the negative terminal to the positive terminal. Very important. Just know that the voltage increase. Okay, voltage increase. Okay, so that also voltage do what? Voltage increase. What does that mean? It means that voltage will be what? Positive. For something to increase means that thing is positive, right? Yes. Then the opposite. Let me clear this side. Okay, so the next one is what? When traveling from positive towards to negative to negative terminal, the voltage do what? Voltage drop. There's actually loss of energy. Okay, so voltage do what? Voltage drop. Now what does it mean for the voltage to drop? It means that voltage will be negative, right? Yes, don't forget the two Kirchhoff rule. That is very important, right? Yes, so first thing you need to do, know the numbers of loop. Second one, assign direction to the loop. Third one is that very important when traveling. This is an important thing. When traveling from what? From negative terminal to positive terminal. What does happen? Where is voltage? Voltage what? Voltage positive. Or you can say voltage increase. Then when traveling from positive terminal to negative terminal, voltage drop or voltage will decrease, right? Yes. So that's tell you that when we are moving like this, when we are moving like this means that when we're moving from negative terminal and positive terminal, voltage increase, right? Then when we are moving from positive terminal to negative terminal, voltage decrease, right? Yes, it means that voltage will be negative, right? Yes. Then the next thing you need to know is that, and this is very important, is that remember I told you guys that current usually moves from what? From high potential to what? To low potential, right? Yes, from high potential to low potential. Now this sign here is known as what? This sign is known as what? This sign is known as what? Resistor, right? This sign is known as resistor, right? Yes. Now take note, this is very important. Next thing is that when can say when the direction of current and the direction when the direction of the current when the direction of the current and the loop direction is the same across a resistor. The voltage so when the direction of the current and the direction of the direction of the loop is the same. Okay, so across the resistor, the voltage usually negative. All right, the voltage usually negative. Okay, so voltage usually drop, or voltage usually what? Negative. Okay, and vice versa. Okay, so when direction of current and the loop direction is the same across a resistor, the voltage across that resistor will be what? Will be negative. okay, and not put now vice versa. What does that mean? It means that when, okay, then when you so then when the direction of the current and the direction of the loop is not the same across the resistor, what will happen to the voltage? Voltage will increase, right? Voltage will be positive, right? Yes. So that is it. So these are things you need to know about Kirchhoff rule. So that is just it. So these are things you need to know. The first thing you need to know is that know the numbers of loop. The second thing you need to know is that assign direction to the loop, right? It can be clockwise, can be anti-clockwise, depends on the one you put. Then the second thing is that when we move from negative terminal to positive terminal, voltage usually positive, means that voltage increase. Then when we move from where from negative for positive terminal to negative terminal, voltage decrease, right? Yes. Then the last one. Now remember this is a now this is current, right? This is current, this is I1, this is current, right? Yes. Now, if you look at this place here, this is the direction of the current. Right? The current is going like this, right? It's going like this. The current is going like this. This is the resistor, right? The current is going like this. Now, what is the direction of the loop? This is the direction of the loop, clockwise, right? Yes, this is the direction of the loop. The loop is still moving in the same direction as what? As the current, right? This direction of the current, this direction of the current, this direction of the loop. So across this resistor, the voltage will drop. Because why? Because the direction of the current and the direction of the loop are what? In the same direction. So therefore voltage usually drop. You know why voltage drop? Because why? Because current usually move from point of what? Higher potential to point of lower potential. Moving from higher potential to lower potential, there's usually a loss of energy. So that is why you find out that there's usually a voltage loss across a resistor when the direction of the current and the direction of the loop are the same. Okay, yes. Then when the direction of the loop and the direction of the current are opposite, are not the same, there will be an increase in voltage, right? Let's say, for example, let's say the direction of this loop now is anti-clockwise, right? Right, we are going like this. Remember, this is the direction of this current, right? This current is going like this, clockwise. While this first loop, the direction of this first loop is what? Is anti-clockwise, right? So if you look in this first one, so you find that the current direction is like this, going like this. The loop direction is going like this, right? Yes. So when the direction of the current and direction of the loop are opposite, are not the same, there's usually an increase in what? There's usually an increase in voltage across the resistor, because where current usually move from what? Higher potential to lower potential. Since we are moving from lower potential to higher potential, there will be an increase in what? There will be an increase in voltage. Remember, current usually move from what? Higher to lower potential, right? Yes. Now, since the direction of the loop is opposite to the current, it means that we are moving from what? It means that we are moving from what? From lower potential to higher potential, right? So across the resistor, there will be an increase in what? There will be an increase in voltage, right? Yes. Now let me break it down. Let me give you guys some. Let me give you guys some that explanation. Okay. So let's say this is the resistor. Now this is the direction of the current, right? This is the direction of the current. Okay, then this is the direction of the loop. Okay, loop direction. Okay, so since current move from a point where there is higher potential to lower potential, and we are moving from what? We are moving opposite to the direction of current. It means that we are moving from what? Higher to lower, right? Yes. I mean, it means that we're moving from lower to higher, whereas current is moving from what? Higher to lower. We are moving from what? Lower to higher. It means that there will be an increase in what? In voltage. So when current, so they take on that when direction of the current and direction of the loop are not the same, that is how opposite. There's usually an increase in voltage, or you can say voltage is positive. Okay, yes. But when the loop direction and the current direction are the same across the resistor, the voltage across that resistor will be negative, or you can say will drop. Okay, yes. So these are the things you need to know about these are you apply Kirchhoff rule. Okay, yeah. So these are the important things you need to know. All right, know the two rules, then know the sign convention. All right, so these are the sign convention. I've already explained it. Right, so the sign convention is that when we move from lower to higher potential, from lower potential to higher from this negative terminal to positive terminal, voltage increase. Right, that is one. Then when we move from when the current direction and the loop direction are the same across the resistor, there will be a decrease in what? Voltage. Then when the current direction and the loop direction is opposite, that is they are not moving in the same direction, there will be a rise in what? there will be an increase in what? Voltage, right? Voltage will be what? Positive. So that is it. All right. Now let's solve this question. All right. So they're telling us to look for what? In this question, they're telling us to look for. They say find the currents. Means that we are looking for what? I1, I2, and what? And I3, right? Looking for I1, I2, and I3, right? So the first thing, we know the two rules, right? We know the two rules. The first rule is junction rule, right? Now, what does junction rule state? Junction rules tell us that the current entering a junction, current entering junction usually equals what called current leaving the junction, right? Yes, in this question, if you look at this question very well, this is the current, like this is I1. I1 is going, I1 is going, I1 pass through here. If you look at it, I1 divided into 2, right? Yes, I1 divided into I2 and I3. So therefore, the current entering this junction is I1, right? This is the junction. Current entering junction is I1. Is equals to what? The current leaving this junction. How many current leaving this junction is what? Current leaving junction are I2 plus what? I3, right? Yes. So just take note. You can call this one equation 1. All right. Yes. Then next rule. Okay. Before we continue, we know that there are two loops in this circuit. And let's give this loop the direction, right? So we can say, okay, let's give the clockwise direction. It means that we start from this place. We go like this, 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 end here. Let's give this second loop a clockwise direction as well. Start from here, go like this, end here, right? So we know the two loops. We know that there are two loops. We have assigned direction to these two loops. Then we move to the Kirchhoff rule, right? We found that I1 is equals to what? I2 plus I3, right? Yes, very important. Then we know the second rule, which is loop rule. Right now, what does loop rule tell us? Loop rule tell us that the total voltage across each component of a resistor, of a circuit, usually equals 0, right? Yes. So let's look now. Let's start from this place. All right. So let's start from this place. Now, what is the direction of the loop? We are starting from here. Like we are going like this. We are going like this, right? Yes. So very important. Know the direction of the loop. Assign direction to the loop. Okay. Follow that direction that you put. All right. So start from here. Like you are going like this. Now, when we go like this, we are moving from what? From negative terminal to positive terminal. What happens to the voltage? Voltage will increase, right? Voltage will be what? Positive. Remember, I told you guys, when we move from negative to positive, there's only a rise in voltage, right? So voltage will be positive. So do like this, we'll say we'll put what we can say 6V plus 6V. Plus 6V is something as well 6V, right? Yeah, so you can say okay, 6. Then plus we are going like this, right? So we have moved from we are going like this, we are going like this, going like this. Remember, loop rules tell us that the total voltage is equals to 0, right? Yes, we want to look for total voltage here, right? In this first loop, right? So in this first loop, let's look at total voltage. So total voltage in the first loop, the total voltage, we start from here, right? The voltage here is positive, right? Then plus we go. Now, what is the voltage in this resistor? Remember, we know that voltage is equals to what? I arrow, right? Yes, we know that voltage is equals to I arrow from Ohm's law, right? So as we are going like this, we are moving like this, right? This forget about currents now. But we are moving according to the direction of the loop, right? The direction that we are sent, which is clockwise. So we are going like this. We approach here. We find that we move from what? From negative to positive, right? So voltage is what? Voltage is positive, right? Yes. So we are going. Now when we get to this one, when we get to this resistor, we find out that we find out that the direction of current here is what? Look at it, that the current is going like this. It's going in this direction, right? This I1 is going in this direction, right? I1 is going in this direction. Same as we are moving like this. We are also moving in the same direction as what? As the current. We are also moving in this direction, right? Yes. Current is moving in this place. Look at this. Current is going like this. We are still going like this, right? We are going like this. Therefore, we are moving in the same direction, right? Yes. Now, since therefore the voltage across this resistor will be what? Will be negative, right? Will be minus what? Will be minus V, right? Now the minus V here, the current it passes through this resistor. So we know that V is equal to I, right? Yes. So the current, the I here is what? V is equal to I. So the I here will be what? Will be I1, right? Will be I1. Then the resistance is what? 4, right? So we have something like this 4I, or we can say I4, we can say 4I, right? Yes. So remember, V is equals to I arrow, right? Yes. Now the resistor here is 4. The resistance is 4. The current is what? Is I1. Right? Yes. Then since we are moving in the same direction, so we are moving in the same direction as the current across this resistor, therefore the voltage will be negative, right? So that's why it's in minus 4 I1, right? Yes. So then let's continue. Then we are moving like this, right? We are going like this. So we are going like this, we are going like this. Then we now come here, we now go like this, right? Yes. Since we are going like this, if we go like this, now this is high theory, right? At this point, I1 divided into high 2 and what high 3. Right? Since this is the first so let's continue. So if you look at if in this place, in this resistor, you find out that direction of high 3, you find out that direction of high 3 is still in this place, right? It's like this, right? High 3 is still like this, and now and the direction of the loop is still what? It's still like this, right? Yes. So therefore the voltage here will still be what? Will drop. Because I told you guys that when the voltage and when the direction of the loop and the direction of the current are the same, there's usually the decrease in voltage, right? Voltage will be negative across the resistor. So the resistor is 9, right? Yes. So the voltage will be negative here, right? So the voltage will be negative. Now what will be the voltage here? V because what? R, right? Will be the current here is what? 3, right? Then the resistance is what? 9, right? So you can say okay. So therefore the voltage is what? We can say 9 R 3, still the same thing, right? Yes. Now the voltage here, will it be positive or negative? To be negative because well, the direction of R3 is like this, the direction for or the direction of the loop is like this. So the voltage will be what? Negative, right? So to be what? Minus 9 R3, okay? So remember, according to loop will state that the total voltage across each component of resistor, I mean of a circuit, usually equals 0, right? So this is total voltage. Total voltage usually in this first loop. In this first loop is what? Is 0. Right? Yeah, this is the first loop, right? So this is total voltage. Okay, the total voltage was 6 minus 4 I1 minus 9 I3, right? Is equals to what? 0, right? So this is the total voltage in the first loop, okay, in the first loop. We can call it equation 2, okay? Yes. Then let's look for a total voltage in this second loop, okay? So let's do it. So the total voltage, you know that total voltage or the sum of voltage usually equals 0, right? Yes. So what is now the first thing we are going to do? We need to know the direction of what? Of the loop, right? So the direction of this loop is what? Is clockwise, right? So we are starting from here, we are going like this, going like this, going like this, and we end here, right? Yes. So now we are starting from this place. So we are going like this, all right? Now if we are going like this, right? Yes, so we are going like this, right? Yes. So okay, so we are done with this first loop. Okay, this is second loop. Now, if we are going like this, remember this the direction of this loop is like this, right? Like this, right? So we are going in this direction. Now, direction of the loop is like this. Then R3 across this resistor, R3 is still passing through this resistor, right? Yes. So R3 is going like this. R3 is going in this place, while the direction of the loop of our loop is like this. So the opposite. So therefore, the voltage across this resistor here will be plus, will be positive, will increase. I don't know if you understand. We are starting from this place, right? We are going like this, we go like this, we go like this, go like this, we end here. Now so that is clockwise direction, right? That is the direction of the loop. The direction of the loop is clockwise. So we start from here like this, we are going. So when we are going across the resistor, find out that the current flowing through this resistor is which is R3 is going opposite to the direction of the loop, right? So therefore the voltage across this resistor will be positive. Remember I told you guys that when the direction of the voltage, I mean when the direction of the current and direction of the loop are opposites, there will be a voltage rise, right? So voltage will be positive, right? So the voltage will be equal to what? I arrow, right? Now what's the I? I is what? The I is what is R3, right? Then the arrow is what? The arrow is 9 ohms, right? It's 9 ohms. So we can just call it 9 R3, right? You can call it 9 R3, right? Yes. Now, what will be the sign of the voltage? Will it be positive or negative? It will be what? Positive because why? Because R3 and the direction of the loop are opposite across this resistor. Therefore, there will be what? There will be an increase in there will be an increase in voltage. Therefore, voltage will be what? Positive, right? So it will be what? We cannot say plus 9 R3 or we cannot say 9 R3 is the same thing. Then plus, let's continue. Remember, when we equate everything to 0, right? Yes. So let's continue. I'm moving like this, moving like this, moving like this, moving like this. Then we reach at this point, we are going. As we are going, the current moving here is what? Is I2, right? Look at it, this is I2. So we are moving, okay? What we are going like this, right? We are going. So this is the direction of the loop, right? Yes. So same with the direction of what? I2. I2 is still moving in this direction, right? So I2 is still moving in this direction. So across this resistor, I2 and and the loop direction are the same. They are going in the same direction, right? So across the resistor, there will be what? There will be a decrease in voltage because they are going in the same direction, right? So with the voltage will be what? V is equals to I arrow. Now the current here, which is what? Is I2, right? Then what is the resistance? The resistance is what? 5, right? Yes. So the voltage is what? The voltage is, we can say 5I2, right? The voltage is 5I2, all right? 5, I'm coming. Voltage is what? 5I2, right? Yes. Then, is the voltage positive or negative? Voltage is negative because why? Look at it. This direction of I1, I2, right? I2 is going in this direction. We are also going in this direction. So we are moving in the same direction, right? Across this resistor, the voltage drop, right? Since they are moving in the same direction. So the voltage will be what? Minus 5I2. So minus 5I2. So it's equals to what? So move like this, we end here, right? So it's equals to what? 0. So we can call this one this. So this is the total voltage across in second loop. Why this is the total voltage what in the first loop? So we can call this one equation what? We can call it equation we can call it equation 3. Why we call this one equation 2? Because this one equation 1, right? Yes. So what are we looking for? In the question, I say you should look for what? Find I1, I2, and what? I3. So let me clear this place. We have already gotten our equation. So there's no need to use this diagram again, okay? So we have gotten our equation, right? So now let's get the current. Okay, so that is just it, okay? So this is this is the easiest place now. Alright, so this is the easiest place. This is the easiest thing now, okay? So we arrived with 3 equations. First equation is we know that I1 is equal to I2 plus I3, right? This is one junction rule, then this is 2 loop rules, right? This is loop rules, right? Yes. So now I want to look for I1, I2, I3. How are we going to look for it? Now let's make use of these 2 equations. So this equation 2 and this equation 3, we want to make use of, to solve this type of question, make use of simultaneous equation, right? Yes, we will use the elimination method. All right, so this equation is what? 6 minus 4I1 minus 9I3 equals to 0. Then this other one is what? Is 9I3 then minus 5I2 equals to 0, right? Now, if you look at these 2 equations, they don't contain two unknown. Like they don't contain the same unknown. This first one contains I1 and I3. This one contains I3 and I2. So we want to make this one as the unknown will be I3 and I2. I don't know if you understand. So this is I1. I don't know if you get. You want to use simultaneous equation. Right? Simultaneous equation, these are 2 equations or 2 or more equations that have the same unknown. Okay. If you look at this, the unknown here in this first equation is what? Is I1 and I3. But this one is what? Is I2 and I3, right? I2, I3, right? Yes. Are they the same? Do they contain the same unknown? No. So we want to make this first equation have the same unknown as the second equation. How are we going to do it? Remember, I1 is equal to what? I2 plus I3. So in the place of I1, we'll put I2 plus I3, right? Yeah, so in the place of this, for I1, you can say, in the place of I1, we'll put what? We know that I1 is equal to what? In place of I1, we know that I1 is equal to what? I2 plus what? I3, right? Yes. So 4 times I2, we get what? 4I2, right? Right? No, I'm coming. Remember, this is minus, okay? So minus 4I1. I1 is equal to what? I2 plus I3. Right? So minus 4 times I2, we have what? Minus 4I2. Then minus 4 times plus 1 and plus I3 to be what? Minus 4I3, right? So that is it. We'll put it in place of this one here. Alright, so let's put it. So this one will now be what? 6 minus what? 6 minus, so it's now be 6 minus 4I2, then minus 4I3, then minus what? 9I3 equals 0. Write down, write the second equation again. Okay, so 9I3 then minus 5I2 is equals to 0. Right? Yes. Therefore, if you look at these 2 equations now, you find out that they have the same unknown. Right? They have These two equations has R3, R2, R3, R3, R2, right? So they have the same unknown now. So we can now use simultaneous equation using elimination method to get the respective current. Okay. Now if you look at these two, these two are the same, right? They contain the same. So this is 4R3, 9R3. Just like like for example, 4A minus 9A, for example. The next one is minus 4B. Okay. Now these two we can subtract them because they contain the same. They contain the same. They are the same, right? Yes, but we cannot subtract 4B from 4A. I don't know if you understand. So look at it. I3. So it's just the same thing as that as 4 minus 4A minus 9A, right? Yeah. So minus 4 minus 9 will give us so minus 4 minus 9 will give us minus 13, right? So that's it. So this place minus 4 minus 4I3 minus 9I3 will give us minus 13I3, right? Yes, so it will be what? Minus 13I3 then equals to what? 0, right? Yes. So we arrive at this. Now we are going to use simultaneous equation to to get to get the unknowns, right? So how are we going to do it? So how are we going to do it? So we use elimination method. Okay, in elimination method, you can go watch the videos on that one. So to solve this question elimination method, okay, let's say we want to eliminate let's say we want to eliminate I2, want to remove them. You want to remove them. We will multiply this first equation with the coefficient of I2 in this second equation. What is the coefficient of I2 in this second equation? Coefficient means something that is close should I say a number close to a letter, right? Or anything that is close. So what is the coefficient of I2 is 5, right? So we multiply this first equation with what? With 5, right? Then we multiply this second equation with what? With the coefficient of I2 in the first equation. So multiply this second equation with 4. Alright, so that's how you want to eliminate I2. So since we want to eliminate I2 in these two equations, we will multiply this first equation with the coefficient of I2 in the second equation, which is 5. Then we'll multiply this second equation with the coefficient of I2 in the first equation, which is 4. Right? Yeah, so this is simultaneous equation. So let's do it. So let's multiply everything. 5 times 6 will give us 30. Right? 5 times minus 4 will give us minus 20 I2. Right? Then 5 times 13. Then 5 times minus 13 I3. Let's do it. So 5 times 13 minus 13 will give us minus 65. So minus 65 I3. Right? So it's equals to what? 0. Right? So what next are we going to do? We know that one equals to I2 plus I3. Okay, so now let's continue. Now multiply. Let's go to the next equation. 4 times 9. All right. So 4 times 9. So that's 36, right? So 4 times. So we get 36 I3, right? Then 4 times minus 5 I2 to what? Minus 20 I2, right? Then equals to what? 0. All right. So what are we going to do next? We what? According to simultaneous equation, we subtract these two equations from each other. Okay. So let's subtract. So if you subtract 30 minus, okay, no, okay, we subtract these two equations from each other, right? So can 30 subtract 36 actually? No, because 30 does not contain actually, so we leave 30 like that. So let's move to this one. Okay, let's start with this first one now. Minus 20 minus 20. I don't know if you understand. The next thing we are going to do is subtract these two equations from each other, right? We want to subtract this equation from this one, right? Yes. So let's do it. Minus 20I2 minus 20I2 will be 0, right? So it will be 0, right? Then let's continue. Minus 65I3 minus 36I3. Remember, these two they are the same, right? Because they contain the same thing. So minus 65I3 minus 36I3. So let's do it. So come in. Alright, so let's do it. So minus 65I3, then minus 36 will give us minus 101, right? To give us minus 101. So give us minus 101, right? Give us minus 101 add 3, right? Yes. Okay. Don't forget about this 30, right? So 30 will just be here, right? Then equals to what? Equals to 0. Okay, so this is what we have arrived, right? Remember, there's no number with a letter here. So and there's no number without a letter here. And even there's a number, we can subtract that from that number. So there's no number here. So this one cancel this, then this will subtract this, right? We are now left with 30 minus this, right, is equal to 0, right? Okay. Or we can say 30 minus 0 is equals 30, right? Yeah, so 30 minus 0 equals 30. Then this two minus 20 add 2 minus 20 add 2 give us 0. Then minus 65 add 3 minus 36 add 3 will give us minus 101 add 3, then is equals to 0, right? Yes. So we have arrived at like this. Now let's look for add 3. So to look at 3, minus 101 R3 will cross this cell, turn positive, right? So that will be equals to what? Plus 101 R3, right? Yes, so that we're going to do, divide both sides by what? 101, right? Remember, we're looking for R3. So I'll cancel this, right? So 30 divide 101. Okay, so 30 divide 101 is 0.29, or we can say 0.29. So our R3 is what? R3 is what? 0.29. Or we can say approximately 0.297, approximately 0.30, okay, ampere. So our R3 is 0.30 ampere, right? Yes. Now, since we have gotten our R3, we can use R3. We can put R3 here and we can use to get R1, right? Yes. Or we can put R3 here, we can use to get R2. So any one of them. Okay, now let's look for the other. Because remember, in this question, I said we should look for R1, R2, and R3, right? So we have gotten our R3. And let's use R3 to get R1 and R2. So it's very easy. So let's get I2. Okay, so let's use this equation to get I2. All right. Yes. So yes, you can use this equation. You can use any of the equation. Okay, you can use any of the equation to get we can you can use any of the equation. All right. So yeah, let's get I2. So 9 I3, right? Now where is I3? I3 is what? 0.30, right? Then close. Then minus 5 I2 then is equals to 0. Then minus 5 I2 cross this side, turn plus, right? So turn to what? Plus 5 I2, right? So turn to what? Plus 5 I2, right? Yes. Now 9 times 0.9. I mean 9 times 0.30. So 9 times 0.30 give us 2.7. Okay, so here will be 2.7, right? Yes, 2.7. Now what I'm going to do, we're looking for R2, divide both side by 5, right? So divide both side by 5, 5 cancel 5, so 2.5 divide 5. So I mean 2.7 divide 5, our answer is what? 0.54. Okay, so I2 is what? 0.54. Okay, yes, 0.54 ampere. Now, what about R1? It's very easy. We can get R1. We can just still impute. We can impute R3 here, then we can use to get R1. Or remember, remember R2 is equals to R1 is equals to R2 plus R3. Right? Yes. Since we have gotten R2 and R3, let's add them. If we just add them, we get R1. So R2 is what? 0.54. R3 is what? 0.30. If we add them, we get R1. Right? So that is it. So let's add them. So 0.54 plus 0.30. Our answer is 0.84. Therefore, our R1 is what? R1 is what? 0.84 ampere. So that is it. Okay. So that is how you. So that is how you solve question regarding Kirchhoff rule. Okay. So it might be long, it might be stressful, but just know the logic. Just know how to apply the rules and all. Okay. So I'll be fast in solving these other two questions. Okay, because I used this first question to explain Kirchhoff rule, right? So now let's do the other question. Okay, I'm coming. So now let's do this next question. Okay, now in this next question, all right. Okay, this next question, let's just look for find R1 and R3. Okay, and please, if you have not subscribed to the channel, please do so. Okay, if you are learning good things here, you can just support us, okay, and also share the video to your classmates. Now in this second question, they said find what I1 and what and I3. Okay, so this is Kirchhoff rule. All right, yes, I'll leave this third question for you guys to solve. All right, so I don't know, let me just solve. Okay, so let me solve this first one. So the first thing I'm going to do is what, know the numbers of loop. How many loops are in this place? It's two loops, right? Yeah, it's two loops. Then next thing is what, assign direction to the loop. Okay, I prefer using clockwise. So clockwise here, right? It means that we start from here, we go like this, end here. It means that we start from here, go like this, end here, right? So that is it. Then now we have known the direction of the loops. Then what is the next thing? We use junction rule to get the current, right? So if you look at it, there are three currents here. If you look at it, one is moving from here. This is I2. I2 is moving from here. Then I1 is going like this. Then it comes, it moves I1 and I2. We find out that I1 and I2 they join together, and we get to what, I3. Now look at it. I1 is going like this. I2 is coming from here like this. Coming from here, coming from here. Then they now join. So we used to give I3. So if I3 goes like this, go like this. I3 divided, right? Divide into I1 and what? I2, right? So therefore, according to junction rule, current leaving a junction is equals to current entering, right? Current entering junction equals current leaving, right? So I3 is equals to I2 plus what? I1. Or you can say I1 plus what? I2, right? Yes. So that is, look at it. Both I2 and I1 joins to give I3. Or if you continue that, you find that I3 will split into I1 and what? And I2. So I3 equals to I1 plus I2. All right. The next thing is, let's look for the total, using loop rule, let's look for the total voltage across each component in this first loop, then across this component in the second loop. Then once we get the total voltage, then we use simultaneous equation to get the current. All right, so now the total voltage across each component in this first loop will be equal to what? According to this loop rule, state that total voltage across each component of uh, of a circle is equal to what? Total voltage is equal to 0, right? Yes. Now let's start from here. Remember, I'm moving like this, right? So start from here. So when we move like this, we are going. Now, if you look at it, our direction of loop is like this, right? This direction of loop. So I can call this DL. So for so that you guys understand direction of loop, right? Then this direction of loop. Don't worry about direction of current. Actually, it's still like this. It's still be like this, right? So direction of current, I can say D high. Okay, call it D high. Okay, direction of current is still like this. Okay, so look at it. Both of them are going in the same direction. Loop direction of loop is like this because we are going like this. Look at it. Start from here clockwise, right? Yes. So direction of okay, this direction of loop, direction of current. Since both of them across this resistor, since that both of them are going in the same direction, so there will be voltage drop, right? Yes, I told you guys earlier. So there will be voltage drop across the resistor. So the voltage drop will be what? V. We know that V will be equal to what? V is equal to IR, right? The current is what? Is I3, right? Current is I3. Then the resistance is what? Is 2. Or we can just call it 2I3, right? Yes. Now is the voltage, is it positive or negative? It's negative, right? It's negative. So therefore we can say minus 2I3, right? Then plus. So we are going like this, we are going like this, we are going like this. Now we come to this place. This is 10V. Now remember, if you look at this negative terminal to positive terminal. Remember, I told you guys, when we move from negative terminal to positive terminal, there's a voltage rise, right? So this voltage will be what? Plus 10 volt, right? Yes. Then plus, let's continue. We are going like this, okay? Direction of the loop is like this, right? So like this, we are going this direction of the loop. Then this direction, that is also, look at it. This current, the current entering this the resistor, is it actually? No, it is I1, right? Look at it. This is I1, I1 is going like this, right? So we found out that both I1 and the direction of loop are the same, right? So therefore, the voltage will be a voltage drop in this resistor, the minus, right? So it will not be what? It will not be minus I arrow. We know that because of arrow, right? So the V is arrow. The I here is what? Is I1, right? The resistance here is what? 6. So you can call it to be 6 I1 or so 6 I1, right? Yes. The voltage will be negative, right? Yes. So plus and minus give us minus. give us minus, right? So give us minus, so it's equals to 0. So this is the total voltage across the first loop. Then what about the second loop? Okay, let's go total voltage across the second loop. Let's see. Okay, let's see. Now this is second loop. Now remember, this is second loop, right? Remember, this is also the direction we assign to the second loop, right? We start from here. Now, if we start from here, we are going like this. Direction of the loop is like this, right? We are going like this, right? So direction of loop is like this. Then what about direction of current? Now, direction, if you look at it, the current, this is I1, the current is going like this, right? The current is going in the opposite direction to the direction of loop, right? Across this resistor. Therefore, voltage will be positive, right? Yes. So to be what? To be plus V equals the I is what is I1, right? Then R is what 6 ohms. Or we can say 6 I1, right? 6 I1, right? So is it plus or negative or minus? Is plus, right? So to be plus 6 I1. Then we continue, we go like this. Then in this battery, if you look at it, direction we are going from what? Since we are moving from what? Positive terminal to negative terminal. So since we are moving from positive terminal to negative terminal, there's what? Usually what? A drop in voltage. Remember, if we are moving from negative to positive, voltage increase, voltage will be positive. If I'm moving from positive to negative, voltage will be more negative. Okay, so this curve V will be 1 minus 10. Right? So we are going like this, we are going like this, we are going like this. Then we are going like this, right? Yes. Now remember, R3, as R3 is going, R3 is divided into 2. R3 is divided into R2. Yeah, R2 is, look at R2. R2 is going like this. And is the R3 divided into, let's say this is R3. R3 then divided into I1, then and what? And I2, right? So I2 is the one going like this is I2, then I1 goes like this, right? Yes. So they now meet here, they now join together and form what? I3, right? So yes, so let's continue like this. We are going like this, we are going like this. So in here, since we are going like this in this direction, find that direction of the loop is like this, we are going like this. Direction of I2 still like this, right? Across this resistor. So voltage across the resistor will be minus, right? So minus 4I2, right? Minus 4I2, minus 4I2. Then we continue, go like this, go like this, go like this. Now, when we get to here, we're moving from what? From positive to negative. Right? You're moving positive negative. Then, therefore, the voltage will drop. Voltage will be minus 14, right? So minus 14, then equals to 0. All right, yes. So this is it. So it's not easy. All right. So don't forget to subscribe. All right. Now what I'm going to do next? Easy. Use some next question. All right. Yes. So before then, if you look at these two equations, do they contain the same unknown? This one contain I3 and I1. This one contain I1 and I2. So what are we going to do? We want to make these two equations have the same unknown. So I can use some next question to solve. So therefore, see this one had I1 and I2. This one had I and I3. But remember, I3 is equal to I1 plus I2. So in the place of I3, we put I1 and I2, right? So that's what doing we get. That's what doing. We make this two equation have the same unknown. So let's do it. So minus 2 I3. Now in the place of, remember, we know that I3 is equal to I1 plus I2. So in the place of I3, we put what? Bracket open I1 plus what? I2, right? So minus 2 times I1, we have minus 2 I1. Then minus 2 times plus uh, I2 to go to minus 2 I2, right? Yes. So we have something like this. So in place of this one, we put this. So now be minus 2 I1 minus 2 I2, then plus 10, then minus 6 I1 is equals to 0. Right? Yes. Now in this one, what is common here? 2 I1 and 6 I1, they are common, right? So minus 2 I1 minus 6 I1 will give us what? Minus 2 minus 6 is what? Minus 8, right? So minus 6 minus 2, minus 2 minus 6 is what? Minus 8. So we can just put it here, we can say here is minus 8 I1, right? Yes, equals to what? 0, right? Yes. Now let's write, worry about this, let's write this one down here. This is the next equation, 6 I1 minus 10 minus 4 I2 minus 14 equals to 0. Right? Now, in this second equation, what is common? Look at it, 10 and 14 are common. Right? They don't take anything here, so they are common. So minus 10 minus 14 give us minus 24, right? So it gives us minus 24. Okay, so let me see, so 4i2 then minus 24 equals to 0, right? Yes. So what are we going to do next? That going to do next. Okay. So if we find out that we have made both equation to have the same unknown, right? This one have that one I2, this one have that one I2. So yes, what I'm going to do next use an elimination method. So since I'm going to use elimination method in some simultaneous equation, let's eliminate I2. Since you are eliminating I2 in these two equations, we'll multiply this first equation with the coefficient of I2 in this second equation, which is 4. Then we'll multiply the second equation with the coefficient of I2 in this first equation, which is 2. Right? So let's do it. So 2 times minus 4 times minus 8 is 32, is minus 32, right? Yes, so let me clean. Okay, let me use here. So 4 times minus 8 is minus 32 I1, right? Then 4 times minus 2 I2 give us minus 8, plus minus 8 I2, right? Then I'm coming. Okay, then 4 times 10 plus 10 is what? Is plus 40, right? Equals to 0. Then let's do 2 times 6i give us 12i1. That's 12i1. Then 2 times minus 4i2 give us minus 8i2. Then 2 times minus 24 give us minus 48, right? Minus 48 is equals to 0. So what I'm going to do next, okay, what I'm going to do next, according to some equation, we subtract this equation from this one, right? So let's subtract it now. Minus 32 minus 32 minus 12 minus 32i minus 12i. I mean, minus 32i1 minus 12i1. Let's do so minus 32 minus 12 will give us minus 44. So I'm coming. Let me write this one here. Okay. So to be what? To be minus 44, right? Minus 44 I1, right? Yes, minus 44 I1. Then minus 8i2 minus 8i2 minus 8i2 will give us 0, right? Yes. Then let's continue. 40 minus 48 will give us 88, right? Yes. 40 plus 40, 40 minus 40 will give us 88, right? Yes. 40 minus 48. Yes, that's 88, right? So that is 88, right? That is plus 88, right? Is equals to 0. So what I'm going to do next? We're looking for what? I1. So take minus 44 I1 to this side to turn plus, right? So now the 88 is equals to plus 44 I1, right? So what I'm going to do? Divide both sides by 44, right? So this one cancel this. So 88 divided 44. I think that is 2, right? Divided 44. That is 2. So therefore I1 is what? I1 is 2. Right? Yes, so I1 is what? I1 is 2. Okay, 2 ampere. What next? Now, we can use I1 to get I3, right? Yes. We can use any of the equation. Okay, we can put I1 here to get I2 in any of the equations. So let me use, okay, let's use, can I use any of this equation? So, okay, let me use this one. Okay, can I use any of the equation? So 6 I1, right? So 6 I1 is what? 2, right? So that is 2, then minus, we want to look for I2, right? So minus 4 I2, then minus 24 is equal to 0. So 6 times 2 is what? 12, right? Then these two are common. So 12 minus 24 will give us, okay, yes, I'm coming. All right. Okay. Yeah, that is it. I'm coming. All right, so let's take this on this side. If we take it to this side to not turn what? Not turn plus 4i2, right? Yes, meanwhile, 12 minus 24 will give us minus 12, right? Yes, give us minus 12. So let's divide both sides by 4, right? If we divide both sides by 4, I2 will be what? Minus 3. So I2 will be what? I2 will be minus 3. Okay, let me check. Let me use another one again. Okay, to see if we have minus 3. Okay. Which one to use now? Let's use this one that still contain I2 and I1. Or yeah, let's use this one. So minus 32 I1 I1 is what? I1 is 2, right? So minus 32 I1 is 2, then minus 8 I2, then plus 40 is equals to 0. Okay, so minus 32 times 2. Minus 32 times 2 will give us minus 64. Alright, so minus 64. Minus 64. Right? Yes. So let's take this one. Let's take this guys the cross. So if minus 64 crosses that side, turn plus, right? Turn plus 64. If minus 40 crosses that side, turn minus 40, right? Yes. So don't forget the minus 8 I2. So 64 minus 40. 64 minus 40. 64 minus 40 is 24. Alright, so this side is 24. Alright, so this side is 24. You want I'm going to do divide both side by minus 8. Right, so minus 8 cancel minus 8. So I have to do what? So minus 24 divided minus 8. 24 divided minus 8 is what? Is minus 3. So we are correct. Minus 3. So I2 is what? Minus 3. Alright, so we are good to go. I1 is 2. I3 is minus 3. Then what about I3? It's very easy. Let's add the two together. Remember, I3 is equals to, from the original equation, I3 is equals to I1 plus I2, right? So I1 is 2. I2 is minus 3. So 2 minus 3 give us what? Minus 1. Therefore, I3 is what? I3 is minus 1 ampere. So that is it. Okay, so that is it. Okay, yes. Then this other equation, I think you guys can solve it. Alright. You guys can solve it. Alright, so I hope you guys understand how to solve questions relating to if you get the answer. If you look at it very well. Let me give you guys scope. Alright, so let me clean this part. Alright, so it's still the same thing. Okay, so this is the let me draw it. Okay, let me draw it so you guys can see it well. Alright, so okay then. Okay, so this voltage is 18 volt. This one is battery 44 volt, 8 ohms, 6 ohms, 3 ohms, 3 ohms, right? Then this is the current. Okay, they said find this current, find this current, find this current. So you'll be confused, right? So it's very easy. So just know that there's not just this current. There are about 3 currents. This and 2 others. Look at it. One current coming like this, joins. The other one coming like this, joins. So you can call this current. You can call this one come here, come here. You can call this one. Let's say I1. They can call this one I2, right? So they joins to form of this one. So you can see this current is equals to I1 plus I2, right? So that is it. So then use the normal way limit we get to solve it. Okay. Yes. So I've given you guys the scope already. I put the other 2 currents for you guys. It's left for you guys to solve it. Okay. If you solve it, put it in the comment section. Okay. So that is just it. Okay. So that is it. All right. Yes. First thing, assign direction to the loop. There are 2 loops. Assign direction. Like what I told you guys earlier. I told you guys that you can point in direction, but I prefer using clockwise. Alright, means that we start from here, go like this, go like this, go like this, end here. Then this other one, we start from here, go like this, end here. So that is it. Okay. Now next one will be part is potential divide.